Number 4 says, suppose the heights in inches of men ages 20 to 29 years old in the United States are normally distributed with a mean of 68.9 inches and a standard deviation of 2.81 inches. So here's your standard deviation, and here's your mean value. All right, so part A says we're going to label the curve 3 standard deviations above and below. So I'm going to start by taking the average and placing it above the 0. Then I'm going to continue to add 2.81 to the right and subtract 2.81 from the left. So add to this 2.81 to come up with 71, 71, 74, 77. Now when I go to the left, I'm going to subtract 2.81. Find the z-score. So z-score is your data point, subtract the mean over standard deviation. So in this problem, we're given 63.28, subtract the average, 68.9 over standard deviation, 2.81. $63.28, subtract average, 68.9, press enter and then divide by the standard deviation. So your z-score is -2. Okay, part C says find the percentage of men that are at least this tall. So you're starting at 71.71 and we want anything that is above it. So I'm going to add up all the percentages underneath the normal distribution curve that are to the right of 1 standard deviation from 0. Positive 1 standard deviation. So I have 13.5 plus 2.35 plus 0.15. So I get 16. So 16% of all men in the United States ages 20 to 29 years old are going to be taller than this height. Part D says, uses the word between. So I want to identify where these two lie on the normal distribution curve. So 60.47 and 71, and I want to go what's between them. So I'm adding up the numbers that are between them. So 2.35 plus 13.5 plus 34 plus 34. Now add those 4 numbers together. $83.85, and it doesn't specify whether to round or not round, but I'd like you to use the exact amount if possible. Okay, part E. Part E is talking about same group of men, and this time we use the terms at most. So you're going to go up to that amount, but you're never going to go over. So 74.25, 74. So at most, we're going to go up to this amount, but we're never going to go over it. So I'm adding everything up to this amount. So 0.15 plus 2.35 plus 13.5, 34 plus 34 plus 13.5. It may have also been easier to add everything to the right of it, just only 2 values, and then subtract from 100 since we know all of these values underneath the normal distribution curve, the percentages add up to 100%. We come up with 97.5%. Okay, so this one sometimes is a little more difficult for students. So first we need to figure out a percentage, and then we apply it to a certain number of men and make a prediction. So we want to know how many men would predict to be expected to be shorter than. So up to this amount or shorter, okay? So we're going to go 66.09 right here. So these are the percentages that are shorter. So I'm going to add up these 3 numbers. 0.15 plus 2.35 plus 13.5. So I get 16%. This equals 16%. Remember, when we're going to actually do this, we turn it back into a decimal. Take it times 250. And we can expect that 40 men out of 250 in this age range in the United States would be shorter than 66.09 inches. All right, so it says 95% of all men are between what? And we know the middle 95 percentile is between -2 to +2. So I'm going to look above and see what numbers on this normal distribution curve are in line with -2 and also with +2. 63.28 and 74.52.